we're going to be identifying features of parabolas. So we're going to look at parabolas in P form or P vertex form. So we have two different ways that they can be written. We have x minus h squared equals 4p times y minus k, where if p is greater than 0, then your parabola opens upward. If it's less than 0, it opens downward. The vertex is at h comma k. The focus is the x-coordinate is h, the y-coordinate is k plus p. The directrix is a horizontal line at y equals k minus p, and the focal width is the absolute value of 4 times p. And again, this will make more sense when we graph it, when we graph an actual parabola. You can also have y minus k squared equals 4p times x minus h. So you have to pay attention to which value is squared. If p is greater than 0, your parabola opens to the right. Less than 0, it opens to the left. Your vertex is still the same. Focus is slightly different. It's the h plus the p value for the x-coordinate and the k value for the y-coordinate. The directrix is now a vertical line through it'll be the x equals h minus p, and the focal width is still the same, absolute value of 4 times the p value. So let's use those to go ahead and identify some features of the parabola and then graph. So we know the vertex is at the x minus whatever our x value is would be the x coordinate. So here it's 2. Y minus the y coordinate, which is 3. So the vertex is pretty easy to identify. There's a couple other ones that are pretty easy. I'm going to skip down to p. So the number multiplied by, in this case, y minus 3, which is 8, that's 4 times the p value. So to find out what p is, we're just going to take that number, which is 8, and divide it by 4. That means that p is equal to 2, because 8 divided by 4 equals 2. So now we're going to use our p value when we're looking at our focus and our directrix. So the focus, okay, so I'm going to show you down here what I'm doing, is at our h value, which is the x-coordinate of the vertex, so 2, comma, the y-coordinate of the vertex, which is 3, plus the p value of 2. So that means the focus is at 2, comma, 3 plus 2 is 5. All right, our directrix is going to be a horizontal line where y is equal to the y-coordinate of our vertex, which is 3, minus the p value of 2. That means our directrix is where y equals 1. Okay, last one, the focal width is the absolute value of 4 times the p value, which our p value is 2. So remember, do what's inside the absolute value bars first. So 4 times 2 is 8. Absolute value just means what is the positive value, because it means distance from 0. So absolute value of 8 is just 8. So our focal width is 8. So I'm going to use these to go ahead and graph this parabola. All right, so I know my vertex is at 2, 3 because p is greater than 0. I know that it opens upward. Okay, my focus is at 2, 5. Okay, I need to use that. So it's really important that I know where the focus is. I know where my vertex is. Okay, the next thing that I'm going to use is my focal width. This will give me 2 more points on my graph. The focal width tells me from the focus the distance out to the next 2 points. So the distance between these 2 points is going to be 8. So that means it will be 4 on either side of the focus. So I'm going to go out 1, 2, 3, 4, and 1, 2, 3, 4. Okay, and so I'm going to go from my vertex up to this point. I'm just going to continue the graph going up from the vertex out to this point. So just a couple other things that you need to check. Our directrix should be where y equals 1. So it goes through right here where y equals 1. Your p-value tells you that from your vertex down to your directrix, it should be a distance of 2, which it is. From your vertex up to your focus should also be the p-value, which is a distance of 2, which it is. So I know that that part's correct. So it just helps me double check that I'm doing it correctly. So go ahead and try a problem just like the one I just did with you. When you're ready, I'll go through the answers. All right, so this one's backwards from the one that we did before where y is in front. So that means our vertex, the x value of our vertex, well, it's x minus the x value of the vertex. Since it's plus 4, I know the x coordinate is negative 4. Y coordinate, y minus the y coordinate, so the y coordinate is positive 1. All right, next thing I'm going to find is p. Well, negative 4 divided by 4 gives us negative 1. Okay, so you can always go back to how to identify the key features if you need to. So for the focus, it is negative 4 plus negative 1, which is negative 5. Okay, and then the y coordinate stays the same. For the directrix, okay, because we have y minus 1 squared, we know it's going to be a vertical line through x, where x equals the x coordinate of the vertex minus the p-value. So negative 4 minus negative 1. Well, negative 4 minus negative 1, change minus a negative to plus a positive. So x equals negative 3. And our focal width, absolute value of 4 times the p-value, which is negative 1. 4 times negative 1 is negative 4. Absolute value of negative 4 is positive 4. Okay, so when I graph this, the vertex is at negative 4, 1. Focus is at negative 5, 1. So I know that my p-value is less than 0. So I know it's going to open to the left. It's going to go this way. So I have to figure out those other 2 points. So I know, looking at the focus, my other 2 points are going to go out this way. So the focal width, the distance between those 2 points is 4. So that means take half of it because each one is 2 away from the focus. So if I graph this, it should look like this. Okay, our directrix is where x equals negative 3. Okay, and since p-value is negative 1, let's just look at the absolute value of it. So the distance from our vertex to the directrix should be 1, and from the vertex to the focus should also be 1, which it is. So you can always double check things. All right, next we're going to identify some features of the parabola, and we're going to create the equation. So first thing, our vertex. Well, that's at the top here, so I'm just going to write x coordinate is 1, y coordinate is 3. So we have 1, 3. All right, so the focus, well, I need to know what the p-value is. Well, I can't identify the p-value yet. I need to do a little math first. So I'm going to look at, I'm given two other points. I'm going to write down their coordinates. This one's -1, -1, and this one is 3, -1. Okay, so I'm going to use that information to find out what p is equal to. So what I have to do is I know that x minus h squared equals 4p times y minus k. So I'm going to plug in some stuff that I know. All right, the h and the k, well, that's the coordinates of the vertex. So I know that h is the x coordinate, which is 1, so -1 squared equals 4p times, I'm going to fill in the x and y in a second, minus the k is the y coordinate, which is 3. Okay, what I'm going to fill in with x and y, or I'm going to take one of these coordinate pairs and use that as my x and y. I'm just going to choose this one, where they're both -1. Okay, now I'm going to solve for p. -1 minus 1 is -2 squared equals 4p times -1 minus 3 is -4. -2 squared is +4 because -2 times -2 is +4 equals 4 times -4 is -16p. To get p by itself, divide both sides by -16, and p is equal to 4 divided by -16 is -1/4. So in this case, p is a fraction, which is all right. So I know that p is equal to -1/4. All right. So then I'm going to look at my focus next. So I know the focus, when it's in this form, I'm going to take the x coordinate of the vertex, and then for the y coordinate of the focus, I have to take the x coordinate of the vertex plus the p-value. So 3 plus -1/4 is 2 3/4. Okay. The directrix. This one's going to be a horizontal line. So this is y is equal to, okay, my y coordinate of the vertex minus my p-value. So y coordinate of my vertex is 3. 3 minus -1/4. Well, minus a negative is plus a positive. So 3 plus 1/4 is 3 1/4. Okay, focal width, absolute value of 4 times p. Well, I'm just going to write this one out. Absolute value of 4 times -1/4. This is the absolute value of -1, which gives us +1. So my equation is x minus the x coordinate of the vertex, which is 1, squared is equal to p times 4. So p times 4, or 4 times p, 4 times -1/4 multiplied by y minus the y coordinate of my vertex, which is 3. This I can simplify. X minus 1 squared equals 4 times -1/4 is -1 multiplied by y minus 3. And I can leave it like this, or I didn't have to write the 1 there, I could just write negative. All right, so I'm going to have you go ahead and try. Oh, you have one more. Okay, so last one. Go ahead and try it out. When you're ready to go through the answers with me, we'll go through them. All right, so vertex. we have 2, -4. All right, so I need to find P. I'm just going to use this point. You can use either point. X is 0, Y is -3. So we have X minus 0. Oops, X minus 2, sorry. X minus 2 squared equals 4P times Y minus, the Y coordinate is -4 of our vertex. So now I'm going to plug in X and Y using this point. So first I just plugged in the vertex. So my X coordinate is 0 minus 2 squared equals 4P times my Y coordinate, -3. But I'm going to change minus and negative to plus a positive, so plus 4. Okay, now I can solve for P. We have 0 minus 2 is -2 squared equals 4P times -3 plus 4 is 1. -2 squared is +4. -2 times -2 is +4. 4P times 1 is just 4P, so divide both sides by 4, and P is equal to 1. So P equals 1. All right, so my focus. All right, so we're going to take the X coordinate of the vertex, and then you take the Y coordinate of the vertex plus P. So -4 plus 1 is -3. The directrix is going to be Y equals the Y coordinate of the vertex minus P. So -4 minus 1 is -5. Okay, we found P. Our focal width. Absolute value of 4 times P. Well, 4 times 1 is 4. Absolute value of 4 is 4. Okay, so then our equation. We have, make a parenthesis, X minus, the X coordinate of the vertex is 2, squared equals 4P, 4 times P, or 4 times 1, which is 4, times Y minus the Y coordinate. Well, Y minus Y minus -4 is the same thing as Y plus 4. And that is our answer.